In this lesson, we will discuss two techniques to compress frequent patterns, which are closed patterns and maximal patterns. We will go over challenges associated with mining large datasets, then discuss closed patterns and maximal patterns. So far, we discussed association rules that describe the relationship between items in a transactional database. For example, a rule of the form X may lead to Y means that if X occurs in a transaction, Y is likely to occur as well. The strength of an association rule is measured using the support and confidence. Here's an example. Suppose the minimum support is set up as 50%. We easily can find the frequent one item set that satisfy the definition: beer 3, nuts 3, diaper 4, and eggs 3. And we were also able to find one 2 item set that satisfy this constraint. Now we set the minimum confidence to 50%, and we try to find association rules that satisfy both the support and confidence from these frequent item sets. We were able to find two rules: beer may lead to diaper and diaper may lead to beer. And remember, to compute the confidence, we take the support of X and Y divided by the support of Y. That's why you can see different confidence between those two association rules, which consists of the same item sets, but in different location for X's and Y's. Key observations: mining, association rules, and frequent patterns are somewhat related problems. So we need scalable methods to find these frequent patterns. However, there are too many frequent patterns, especially the minimum support is not that selective measure. To make a point, let's go over this contrived example. Suppose we have two transactions in this database. T1 goes from A1, A2 all the way to A50. T2 goes from A1, A2 all the way to A100. Now I want to list all frequent patterns with minimum support equals to 1. So for one item sets, I have 100, two item sets, 100, choose 2, and so on. So we ended up with an overwhelming number of frequent patterns. So it makes sense to focus on the subset of patterns that matters the most, which leads us to closed patterns, which compresses the number of item sets to consider. Here's the definition of the closed patterns. A pattern or item set X is closed if X meets two conditions. First, X needs to be frequent, and there exists no super pattern Y that already contains X with the same support as X. So this is very important. I don't have a larger subset that contains X and they share the same support. For the previous example, the T1 and T2, we end up with two closed patterns. A pattern that goes from A1 to A50, and we will have two of those. One comes from T1 and the other comes from T2. And then we have from A1 to A100, we have one pattern of this form. Here's an exercise to practice finding closed patterns. Suppose we have 3 transactions. We need to list closed patterns with minimum support equals to 1 and minimum support equals to 2. It's a good idea to start with visualizing what goes inside the patterns, because we want to look at the overlap, which means this suggests we have more than one pattern with the same support. Also, I need to see if there is a larger superset that contains another subset, so I can double check what the definition needs me to do. Now, as you can see, we ended up with 3 patterns. From A1 to A10 occurred twice. From A20 to A25 occurred twice. and A1 to A25 occurred only once. For minimum support equals 2, I'm going to focus on the overlapping areas, which means I got from A1 to A10 twice and from A20 to A25 twice. A very important property of a closed pattern, it's a lossless compression, which means it's going to reduce the number of patterns without losing the support information. So in our very first example with so many frequent patterns, we were able to get two closed patterns, the one from A1 to A50 with support 2 and A1 to A100 with support 1. We didn't lose any support information. Any subset from this pattern, it will always going to have a support of 2. If you look at A2 to A40, the support is 2. Similarly, for the larger pattern P2, if you look from A5 to A51, the support is still 1. So the support information remained intact. Another form of compressed pattern is called maximal or max patterns. So a pattern X is maximal pattern if X first is frequent and there exists no frequent super pattern Y that already contains X, and we stop here. We don't add more constraints. So how does it differ from closed patterns? We really don't care about the support of sub-pattern in max patterns. Let's say we have two transactions from before, the one with A1 to A50 and A1 to A100. The max pattern is just going to be from A1 to A100. Here's an exercise to practice max patterns. So I have the three transactions and I need to find max patterns for minimum support equals 1, equals 2, and equals 3. So when minimum support equals 1, I'm going to get one big pattern that contains everything. So here I got A1, A2, all the way to A25. Now for max pattern with minimum support equals 2, I got from A1 to A20 because A1 to A25, the support is 1. So I only have two overlapping areas between T2 and T3. Finally, for min support equals 3, we are going to look at the overlapping areas. And as you can see, from A10 to A20 occurred 3 times. One final note, maximal pattern is actually a lossy compression because we only know the support of the maximal pattern, but we lost the support information of the subsets. So if, let's say, A1 to A40 occurred 5 times, but A1 to A100 occurred 1 time, then we lost this information. So we use closed patterns more than the maximal patterns because they are more reliable and captures more information. In summary, we discussed techniques to compress frequent patterns. We talked about closed patterns and maximal patterns.